Flipping over to Visual Studio, I have a really simple application that asks you for a number, and I'm going to work out if it's prime or not. So I'm going to assume it's prime, and then I'm going to go through a while loop looking for factors. If I find a factor, it's not prime. If I come all the way through the while loop and didn't find a factor, it must still be prime. I'm using a different operator. I'm using less than or equal to. Hopefully everyone can recognize that. And this is a bit of a trick if you haven't done a lot of calculating of primes. It's enough to go until the number you're testing as a factor is larger than if I were to divide that number into the original number. So in the case of 102, if I would divide 51 into it, getting 2 is less than 51, so I've already tried the other half of the factor, in other words. So this is just a little optimization to make your loop go faster, and I am really only including it so that you can again see that we can have more complex constructs in our conditions for our whiles. So what do I do each time I go through this loop? I try to figure out what the factor would be, and I'm taking something that's almost certainly not an integer and putting it into an integer. We talked about this in data types. That's going to silently truncate the result, which is exactly what I want. So if I'm testing whether or not 2 goes into 7, I'll take 7 divided by 2, get 3 in a bit. That'll get truncated out to 3. Then on the next line, I multiply it back. 3 times 2 is 6, which is not equal to 7. So in this case, this if would fail and would come out. When it does equal, it's because the number is actually a factor. Now we'll talk more about operators later, but I do want to show you the double equal sign being used for testing equality in C++. Something in the operators section, we'll talk more about that, just pointing it out here. So if we did find a factor, we'll print that out. Normally apps don't, but I'm trying to be transparent here and set our Boolean prime to false. Super important, if you're going to do a loop with a while, you have to do something to move you towards getting out of the loop. If you're looping while you read a file, you should read another line of the file. If you're looping while you process a data set, you should move on to the next row of the data set, and so on. Here, I'm just going to increment I. There are better ways to increment I, but those can wait for the operators material. That's the loop. Once we come out the other end, we can test that Boolean variable prime and print out, using our newfound if skills, whether it's prime or not, and that's the whole application. So I'm going to run it. Let's test 7. 7 is prime. Okay, let's run it again. Let's test 25. 25 has a factor. Makes sense. 25 is not prime. Now, I have a little bit of an optimization in this app in that I only go up as high as I need to and not all the way until I've tested up to the value x of the number I put in. But I have an inefficiency still in place. Let's try running one more time. And this time I'll put in 12, a number that has a lot of factors. You see it finds the factor 6 and 4. It concludes that 12 is not prime. But as soon as we found the first factor, 6, we knew 12 wasn't prime. There's no need to continue to go on and find other factors. I can make this exit once it's understood that, oh, this isn't a prime number. This is a great use of the break keyword. Break gets you out of the loop you are in. So here, it doesn't get you out of ifs or anything. It gets you out of whiles, and when we do fors, it also gets you out of fors and some other constructs. So what will happen is if we find a factor, we'll break out of the while loop. And rather than incrementing I and going back up to test again whether or not I is still less than x divided by the new I, we'll just come straight out to the line after the close brace of the while. And this just makes the code in this example a little more efficient. You wouldn't do this if you wanted to find every one, but it's common idiom to have to find the first of something, and this is a simple way to stop once you have found that first one. So I'll run it. And again, we'll do 12. This time it only finds the factor 6. It doesn't go on and find the factor of 4 because break took us out of the while. You can see that once you know if, you also really know a lot of the rules around while. Pretty straightforward.